Hey guys, today's Thursday the 23rd. Today we are going to be learning about limits, and we've already been working on these. Yesterday we were working on estimating limits graphically and numerically. Today we are going to be working on evaluating them, which means doing them algebraically. We can still use what we learned before to help us check our work. But now we'll have a concrete way to know whether it's the correct answer. So let me show you first this information. So the limits of functions. Here's what we know. The limit as x approaches c of a constant, linear, polynomial, or rational function is always equal to f of c. So basically, for any of these functions, I gave some examples for each one. As x is approaching c, whatever the c value is, you can just plug that into the function, whatever the number is for c. You can plug this c value into the function and simplify it, and you'll know what the limit is approaching. Let me show you an example. These are pretty easy, so I already just wrote them out for you, so we can just go through them. So the first one, using what we just learned, evaluate each limit. The first one, this is a polynomial function. So I know that I can just take my c value and plug it in for the function. So my c value here is 4. So what I'll do is plug in 4 for every value of x and simplify, and you get negative 10. For the next one, this is a rational function. And my c value is negative 2. So what I can do is plug in negative 2 for every value of x. When I do that, I simplify, and I get 31 over 7. Remember, you could always check these on your graphing calculator too, and it should look like the graph is approaching this value. The last one, my c value is 3, so I plug in 3 for x. So I did that here. Remember, to the 1/2 power, this is the same thing as square root. So 5 to the 1/2 power is the same thing as square root of 5. You could plug this in and get 2 point whatever also, that's fine too. Alright, sometimes when we try to evaluate a limit, we get a problem. So let's look at this. This is example 3, and we're going to have to use factoring this time. So if we were looking at this problem and we try plugging in negative 4, the c value for our variable, what happens is that we end up getting 0 over 0, which is called an indeterminate form. Whenever you get an indeterminate form, you have to do something to the function before plugging in the c value. So on this function, I see that my numerator could factor. So what I'm going to do is I'm first going to factor out the numerator. So basically what I did was I thought of two numbers that multiply to give me negative 20, add up to negative 1. Those two numbers are positive 4 and negative 5. Just as a quick little hint, one of your factors up in your numerator or denominator, depending on what you're factoring, is most likely 99.9% going to match what you have in either the numerator or denominator. So the reason that is so that it can cancel out. So for this one, we can cancel out the factor x plus 4. So we'll cancel that out, and we're left with the limit as x approaches negative 4 of x minus 5. Make sure you always keep writing down the limit until the final answer when you're actually plugging in the number. So now we can go ahead and plug our number in. So now it's just like example 1. Our c value is negative 4. We're going to plug that in for our x, our variable. So we get negative 4 minus 5. So the limit is negative 9. And you could double check that on your calculator. When you double check it, you want to type in the original function to your y equals screen, and then see what is the y value approaching as x is approaching negative 4. Remember, you can also look at your table. Okay, this one is a similar problem where we had to factor it. I just wanted to go over this one because I think we might need to go over this factoring. So for this one, we obviously need to factor out the denominator because the numerator doesn't even factor. And the reason I know I have to factor is because if I tried plugging in 3, I'm going to get 0 over 0, an indeterminate form. So I know I have to factor or do something else before I can solve. So to factor this denominator, what I need to do is factor by grouping. So in order to factor by grouping, I need to have 2 groups, and the first group is going to be the first 2 terms, the second group is going to be the second 2 terms. And you always have to have a plus sign between your 2 groups. Once you group them up, you take the greatest common factor out of each group. So out of my first group, I can take out x squared, because the greatest common factor of x cubed and negative 3x squared is x squared. In my second group, my greatest common factor is negative 7. Whatever you take out, whatever you're left with after you take out the greatest common factors should be the same. So, for example, x minus 3 is the same as x minus 3. So since x minus 3 is in both the first group and the second group, I can go ahead and bring it out. So I'm factoring out x minus 3. In the first group, I'm left with x squared. And in the second group, when I factor out x minus 3, I'm left with a negative 7. Remember, you could also use guess and check for this, but factoring by grouping will always work, and it might save you some time. So once I get it factored out, now I see that I can cancel out this factor, x minus 3. So when x minus 3 cancels out of our numerator, you have to be left with a 1 in the numerator, and you're left with x squared minus 7 in the denominator. Once you're ready to plug in your c value, now you can drop the limit on the next step. So notice I did not write limit here anymore because now I'm plugging in my c value. Now I just have to simplify. 3 squared is 9, 9 minus 7 is 2, so the limit as x is approaching 3 is 1/2 for this function. And you can double check this on your graph. You want to look where x is approaching 3 and double check that y is approaching 1/2. So for all of these, make sure you check it graphically and or numerically, which means on your table. So that's like what we did in goals 1 and 2. Maybe you already thought ahead. Remember in your daily reflection question from the other day, it said, how do you think you can use goals 1 and 2 in what we are doing for goal 3? Maybe you already thought of the idea that you can use it to check your work for goal 3. If you did, that's awesome, you're correct. Okay, this one. Let's look at this. Evaluate the limit as x is approaching 25 for radical x minus 5 over x minus 25. Notice if we try plugging in 25 directly, it gives us an indeterminate form 0 over 0. So we know we have to do something to adjust this function before we plug in 25. So for this one, factoring does not look very convenient. So what we can do is use rationalizing. So basically what I mean by that is we need to multiply by a sneaky 1. So your sneaky 1 is going to be the conjugate of the one that has the radical. So either the numerator or denominator, and you're using the conjugate. Remember the conjugate, you keep the radical x and the 5, you just change the sign in the middle. And make sure it's a sneaky 1, so you have to do it in the numerator and the denominator. Now we can multiply this out. So wherever you're multiplying the conjugate, so in this case we're multiplying by the conjugate of the numerator, we want to FOIL the numerator. So we're going to FOIL the numerator, but we want to keep the denominator. The reason for that is because we are going to end up canceling out this term x minus 25. So FOIL out your numerator. Radical x times radical x is x. outsides, insides last. You can do that. And keep your denominator. These two middle terms cancel out, positive 5 radical x and negative 5 radical x. So we just have x minus 25 in our numerator. Now this is what I said, x minus 25 is going to cancel out. Make sure when you cancel out the entire numerator, you're still left with a 1. Okay, so now we can go ahead and try plugging in 25, and this time it will work. So we can drop the limit in front. Notice when we're plugging in the actual number, we drop the limit. But make sure you do not drop the limit until this step. So notice we kept the limit throughout the entire problem until we actually plugged in the number. So now we plug in 25 for x, we get 1 over 5 plus 5. So our answer is 1 over 10. And again, we could check this on our calculator using the graph or the table, or both. Okay, your homework for tonight is on page 754. You have numbers 12, 14, 20, 26, and 30. And your daily reflection question is this: what questions do you still have about this goal? If you don't have any questions, write a similar problem and solve it. Have a great rest of your day, guys. See you tomorrow. Bye.